Hello guys, welcome back to our YouTube channel. We are Destiny Design Builders Hub. Today we are going to design RC reinforced concrete design. This is what we are going to do now. As I was told you in the previous video, this is our simple building. The previous time we did about steel design. So let's continue about our RC design, reinforced concrete design. Let me just back our cloudings, go on display, on panel thickness, or filling the interior. Let's say okay. That is our cloudings. So as I told you, in doing RC design, we are going to design RC columns, RC beams. In RC columns, you have to check well the reactions, the variation of reactions you have in your structure. While in designing RC beams, we deal about the moment. So in checking the result, you have to make sure the result you are using must be given by ultimate combinations. This is our ultimate combination one. You can check the reactions. Place here on result diagram for bars. Go or here on reaction FZ. Check well those three are ticked. Diagram for linear support, description and average value. Apply. That is our reaction. If you want to make it normal, if you want to look those reaction well, you can zoom and then you normalize. So get a look where we are seeing them well. So our maximum reaction we have here, it's that is 79.76. Get a look at those reactions we have here. Those reactions, they are varied, they are looked like similar. So pick the one that shows us the highest value. Let's pick this, and then take it this node 11. It's important. You can write it somewhere, you note it somewhere. The column we are going to design has 11 as nodes. Before starting doing RC design, you have to make a full design of this wall structure. Go here on design, come up here, required reinforcement of beams and columns. The first one, required reinforcement of RC beams and columns. And then you make sure you have, this is ultimate method that place here, you go here on combination, pick those combinations, ultimate combinations, if you have serviceability limited state, you can go here also, you pick it and then you insert there. For this building, we have none serviceability limited state. So let you calculate. Okay, structure calculations. Okay, close. So after putting all those combinations, you've checked all about legitimate limited state, serviceability limited state. You can just calculate and then go here, you back structure model. This is how we make back in robot structure analysis. Then start. Okay, you can normalize to see them well. The action we are going to design has 11 as node. You select those columns along chain from sub columns up to the end. So you come here, go here on RC design, place here the first complete member. You're going to here you pick RC member, the first complete member, required reinforcement. Then you calculate. Close. After create, you pick here. This is if you put your cursor here, you can read. This is provide reinforcement of RC element. Let's place here. You have to make sure you are selected manual combinations and automatically run calculation. Then okay, this is our columns. This is our column chain. Here you can pick the one you wish. Then go here on calculation note. You can just start to read your calculation note. So because as a structural engineer, you know what exactly required on site. You have to change and you choose the material you wish that will be used on site. So here, do this. Press here on calculation options. Go here on concrete. Make sure here the material you have is you have a concrete mix C25. You press here on utility reinforcement. Grade of the steel. We use the steel the steel which have high yield steel. Here we are using, as I told you, here we are using a British standard. Our characteristic strength of our steel, we are going to use. They will have 460. Then okay, here come up here on longitudinal reinforcement. You choose grade of our steel. We are going to use CT. Our steel that we are going to use will have characteristic strength of 460. Then here you can choose the diameter of the steel reinforcement you wanna use. Here let's we pick 12. Come up here on transverse reinforcement. Grade of the steel. Use the steel of which is high yield steel. Characteristic strength never change. Press here. Let me use 8 on transversal reinforcement. So press OK. Then press here on reinforcement pattern. It's better if you close these double bars. I think it's enough. Then you can just make calculation. Here, this is unsatisfactory loading capacity of the column. Means you have to deal with the size of the column. To deal about the size of the concrete, you are dealing about the concrete. You can just deal about the reinforcement. Here we have two options to deal with the concrete, to deal with the reinforcement. Yeah, press OK. Get the log. We have 8. This is the reinforcement there, but our column is not yet passing. You have to change it. Let we increase the section. I'm sorry. Press here on column geometry. Let me increase these columns. Let me use 250. Our sub column with 1.5. Press OK. Then let's calculate. Our column is already passing. Let we see the reinforcement are there. This is our reinforcement. T6. We have 6 bars of a diameter of 6. Also, press here on the second column chain. This is column chain. Yeah, place here. Put the concrete, mix red, and let's fix 12 reinforcement. 20% reinforcement. Let's say we choose 8. Press OK. And then geometry reinforcement option pattern. I'll go here on door. It's better if you close it. Okay, press here on geometry, change relative change to get the column with the similar section. Here we have 4 meters. Okay, let's calculate. Okay, our column is passing. Also, we have 6. The software is given to us 6 bars of 8 diameter. So it's already passing. Let's see our calculation note. Okay, you are looking. Yeah, that's well. This is how we are. That is how we design RC columns. As a structural engineer, it does not well. This is our concrete mix of strength 25 megapascal. This unit weight of concrete. This is our steel material. The material of our steel bars we used. This is the strength of them. This is the section. This is the height. This is the slab. This is the beam height. Okay. This is the moment we have here. Okay. Get a look. our column here, it is a cylinder column. We can make it as a short column to be blessed column. So here you have to choose the section of the column that can keep your column to be short. So go here on column geometry. Let we make it 300. Press OK. Then you calculate. Okay. This is for 12. So here the concrete is is too much compared to the steel. Here you can put additional reinforcement. Let's go here. If you wanna add more reinforcement to balance your concrete and the steel, you can come up here on reinforcement pattern. Go here on longitudinal bars. Press here. Let's put 8 bars there in our columns. It means at any side of a column we count 3 bars. I will show you. Press OK. Then you calculate. Let me just show you. This is 1, 2, 3. This is 1, 2, 3. Means we have 8 reinforcement. You can see how it is. This is our columns. This is 8 bars of 12 diameter. So this is our calculation note. So you can change it here on our sub columns. Press here on column geometry. Put 3000. Press OK. Let's here again put 8 bars of 12 diameter. Press OK. Then you calculate. That is our column. Okay, well, you can check it also. This is our sub columns. Okay, well, this is our calculation note. You can save this calculation note in the place where you want. Means at the end you will collect those calculation notes, the required calculation note, then you combine them in this software, then you print them. So okay, let's deal about the foundation of this column. So go here on RC element, new foundation. Also here, this is our section of our footing normally. Normally it has 2 meters one side, 2 meters on the other side. A column normally it has 65. This is the eccentricity of a column. You can fix it as well if you wish. If you want to put our column in the center of the footing, but reticulated it. So we need to. This is our sub column. Let me put our column normally where our sub column will be inserted. That will be this 1.5 meter will be increasing due to the site dimension. Let's put 1.5. Then you apply. So by applying, you are seeing it well. So go here on other element. Let's put our column we have. This is our sub column. Yeah, look here. This is our column. Has this section 30 one side and also 30 centimeter in the other side. So this is our sub-column. This is 1.5 meter. So this is concrete bindings. So we need to put the reinforcement there. Let's be sure the software the reinforcement diameter we wish to use. Go here on concrete. Declare the concrete mills. Change the reinforcement. Declare that we use also the steel we are going to use with the big high yielding steel. We have also this strength. So let's import 12. Transfer reinforcement. Also, and let's use 8 addition reinforcement. We don't need it, but you can put the grade of the steel if it is needed. So press OK. Also here, we go here on soil definition. I'm going to explain well those two things we have here. This is the two options of our footing that give a different result. So you have to try it by using your computer if you want. Here on NA, this is the level where we shall put our sub-column. So here we put 1-1.5 as the level of the sub-column. Let me say our sub-column will be inserted in the soil within -1.5 below the soil, and here we declare it to put a 0. Then we apply. Means here I'm not sure that the sub-column will be below the soil under this 1.5 meter. This is the option 1, and if I put 0 here and I put -1.5 here, means this option shows that if you are sure that our sub-column will be inserted in the soil below the soil within 1.5 meter, you can use this option. If you are not known, you can use the option 1. So let's use this option. So close. Go here on geotechnical option, stress allowable. Then let's use 0.25 as bearing capacity of the soil. Bearing capacity of the soil means this is the capacity of the soil to support our structure. Then okay, you can just make calculation to see the section of our footing that we shall use on site. Calculate. So get a look. Our footing is 0.4 one side and the other side 1.4, which is so small. So you can fix it because here we don't have more axial force. So to make it normal, you can fix it. Let's put 1.2, at least 1 meter, and here 1 meter. You fix it, then you apply. So here, then you make calculation. So this is how we design a footing under a certain agraphos or reactions within any columns we've just designed. So this is our calculation note of footing. So you can try it, then you read it well, those calculation note. Those are the reinforcement we have there in our footing. In x-axis we have 4 bars. Along y-axis we have 4 bars too. So you can check it also, you can press here on drawing. So this is our footing drawing. So here, this is our calculation note. So you can save it somewhere. You go on file, save as, save as. You can press it somewhere you want. Then okay, well, okay. Let's we do also on. Let's we go back structure model. Let me design beam. Let me hide those reactions. Press on none to remove those reaction. Then apply. And because we are going to design the reinforced concrete beams. Press here on NTM. We need the MY moment. Apply. Those are our moment. At the moment, let's we go here on display panel, filling the interior, then you want to tick on filling an interior, then you press on. Okay. So go here on parameter, make sure label differentiated and the field are ticked, then you apply in order to get the values. So you can read it some those values. This is the moment we have. If you want to make it normal, so press here and then you normalize to see where those values where they are. Okay. Those moments are in the still. Okay. In designing RC beam, we did about the two type of moment. We did about the in the positive moment and negative moment. Here in robot they are shown. You get a look. This is the negative moment. This is the positive. This is the positive moment. Get a look. Positive moment and negative moment in the beam. In the normal building, you can find them there, but here this our simple building looks like a warehouse. Means because of its flame, our pot of flame, it shows us we have a moment there in the columns. And somewhere in the steel trusses, but no problem. Let's find the beam with highest value of moment. Okay, we have highest value is here. Let's see, we design this beam. Okay, let's design this beam. First, you have to select the beam at a certain span you want to design. Then you go here, RC design, RC member required reinforcement. Then you make sure those combinations, ultimate and serviceability are declared while there, and then you calculate, close, then go here and provide reinforcement. Plus make sure on manual combination and automatically run calculation, then you press OK. Yeah, our beam has this section 20 and 40 centimeters. Then close it. You can just start with the calculation note. You can see the reinforcement. Normally, a software has just generated. So, as a structure engineer, you know well all about information are there on site. So you need to change it, and you put anything you want. Go here on concrete. You make sure you put the material of the concrete mix. It's a concrete that will be mixed under this ratio C25. Go here on limited reinforcement. Grade of the steel. Also we need it. Let's use 12. Transverse reinforcement put 8. Then additional reinforcement we don't need it, but you can just put high rhythm stiff and place OK. In RC beam, what we did it's enough, so you just calculate. If you check well they are passed, you check well our beam is passing well. Go here, you can see the reinforcement the software have been put there. We have 4 steel bars, bottom and top. In the bottom you have 2 bars of 12 diameter, and top also we have 2 bars. Get the rock, we have 4 bars. You can just see there on RC reinforcement to see well how reinforcement are arranged in your beam. Okay, you can see we have 4 steel bars, so it's enough for the beam. What we need is a correction note if our beam is passing well. We don't need anything more than this, so it is passing. That is you go here. Let me just take back. Yeah, we go here on drawing. You can see it. This is our structure details. Our software robot is generated about the beam. that will be just designed. So get a look. So this is how we design RC beams. You can just save this note if at any way you wish. You save file, you save as you can just name it and you put it somewhere you wish. Okay. If everything's done, uh, okay guys, you can press done on reaction, done. Okay guys, that is the end of my video.